So you will have to pay attention to one aspect of labeling the periodic table. All right? You have to realize that these are the energy levels that are getting filled in by the electrons outside the nucleus. All right? So, what energy level is closest to the nucleus? It's the 1s. All right? It's first the 1s, and then what is the next energy level? 2s. Then what fills in? 2p. Are you with me? These are distances as they move out. All right? After the 2p, what is the next energy level that fills? 3s, 3p. Notice this. The next one is 4s. What fills after the 4s? It is the 3d. After 4s, it is 3d. Then what fills in? 4p. It's almost like people occupying seats in an arena. Is that right? So the electrons will occupy the lowest energy level first. And then gradually, they'll start occupying the higher energy levels. And we really have to know this order. Does that make sense? The order in which the electrons are being filled in inside the atom. Now, back in my days, all right, we used to learn how the electrons, why is this not moving? Okay, it's going crazy. Like back in my days, we used to use this to understand which energy level filled in next. Does that make sense? So this chart here tells you which electron level. It's 1s, then we used to draw arrows. 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on. Nowadays, we don't use this. We go straight to the periodic table, and we use the periodic table in order to understand how the various energy levels are filled. Okay. So how do the electrons fill in when you use the periodic table? You must start filling the electrons in from the 1s energy level, which is closest to the nucleus, and you almost follow the periodic table as if you are reading a sentence in a book. All right? You fill in the 1s. There is no 1p. Then you fill in the 2s. After you fill in the 2s, you go to the 2p. Then you fill in the 3s. Then you go and fill in the 3p. Then you fill in the 4s. Then the 3d. Then the 4p. Is it making sense? Well, after the 3, what is the next energy level? 3s. It's the 3p. You start. Once you finish that sentence, you start in your left again, right? What do you fill in next? 4s. What fills after 4s? 3d. What fills after 3d? 4p. And then you come back. What fills next? 5s. Is it making sense? Yes, Sam? Okay. Okay. So, if you notice the periodic table very carefully, all right? So, here is my periodic table. You must follow atomic numbers, all right? So, let's look at the periodic table. What is this atomic number? 56. What is that? 57. What is the next one? 2. What? After 57, 58. Where is 58? Down below. All right? Kind of, the periodic table actually looks like this. Should look like this. So you have the S block. You have one column of D block. And then this should be the F block. All right? That should be the B block. But the periodic table doesn't look like this. Is that right? So let's, more of the D block should come here and then it's the p block. Is that right? So it should be S, D, F, more D, and then P. Is that right? Kind of it got chopped off. Is that right? Because it doesn't fit the paper. The logic is very simple. If you want to fit the periodic table into an A4 size paper, and it actually has to be legible, as it is the elements' names are written so small, they just cut it out for convenience and put it in the bottom. Is that understood? All right? Now, so you have to follow the periodic table as you start writing the electron configuration of the different elements. Yes, John?
So the thing on the bottom is also a D?
It's an F. It's the D fills.
Where's the extra D?
So we will come to those special cases. We'll do one or two of writing those electron configurations when we come to them. All right? So let's start writing electron configurations. Okay? So when I write an electron configuration, this element is hydrogen. Is that right? So hydrogen has how many electrons? 1. Where does that first electron in hydrogen go? It goes to the lowest energy orbital, which is the energy level 1. It's an S, right? Within the first energy level, it's the subshell or the shape of the orbital. Is that right? And how many electrons occupy it? 1. So what does the 1 here indicate? It indicates the energy level. My smart board is not that great. I don't know if it's still thinking. This is the sub-level or kind of the shape of the orbital into which the electron goes. And that denotes the number of electrons that are there in that particular orbital. Are you with me? Helium has how many electrons? 2. Yes, Mr. Thompson. Is it in the printer? Yes. Yes, I didn't finish copying. The printer was acting up. All right. So helium has 2 electrons. Is that right? How do you write the electron configuration of helium? 1s, 2. So how do these 2 electrons, how are they present in helium inside the s orbital? One is spinning clockwise, the other is spinning counterclockwise. Remember, the electrons are negative. They repel each other. They are like charges. So they'll spin in the opposite directions. Is this understood? Okay? Stay with me for some time till we finish writing electron configuration. Write a question down. You're going to ask that later. All right? So now we're going to go ahead and write a few electron configuration for the elements that we know. Just align this first. So much pain. Okay, so we're going to go ahead and we are going to write the electron configuration for a few elements. All right? I'm going to start writing out the electron configuration of iodine. Do you now have your whiteboard filled out? Can you go ahead and fill out your whiteboard with the SPDF orbitals and the energy levels? Do that quickly, guys. Fill out the whiteboard and follow along as I write. With your finger, follow along. Alright, you don't have to decorate it too much. Just number the energy levels, and I need to get started. Okay, so all of you located iodine. You have iodine. Alright, so how do I write the electron configuration of iodine? It is 1s2, correct? What comes after 1s2? It's 2s2. Are there 2 electrons that can go into the s orbital? Is that right? Where is iodine? Group 6 right here. Right? This is the 1s2. Maybe I'll do it here. 1s2. There is no 1p. 2s2. After I jump, it's the 2p. 1, 2, 3, 4, 5, 6. It's 2p6. Alright? After 2p6, it's 3s2. Correct? Then it's 3p6. Alright? After 3p6, what do I come down to? 4s. It's 4s2. Thank you, Mr. Tennyson. What is after 4s? 3d. And how many in the D? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 3d10. What is after 3d? 4p6. What is after 4p6? 5s2. What is after 5s2? 4d10. 4d10. And where is 5p what? 5p6. It's in 5p. Is that right? I labeled it wrong. It's 5p6. Not 6. 5p 5. Does it end at 5p5? Yes, John.
You record this?
I'm recording it. It's all being recorded. I'll post it. Alright? Now, are we good? Did we follow along? Did you understand how I wrote the electron configuration? Alright. Okay, but let's do this for potassium. Did you locate potassium in your periodic table? Did you locate potassium?
Yes.
Alright. I'm going to write the electron configuration. 1s2. What fills after 1s2? 2s2. What fills after 2s2? 2p6. What fills after 2p6? 3s2. What fills after 3s2? 3p6. What fills after 3p6? 4s2. Wait, potassium is 4s1. Are we getting an idea of how this is being filled? Yes. The exponents are the number of electrons that can go into that particular orbital. Alright? Guys, remember, this is, if you follow patterns, you can count boxes, Ryan. Counting boxes makes life easier for us, right? P has 6 boxes, and we say there are 6 electrons. But if you're actually asking for the connection, remember, each orbital can have how many electrons? 2. So in the s orbital, 1s is 2. 2s is 2. What is after 2s? It's the 2p, correct? How many different p orbitals are there? 6. But they come from the 3p orbitals that are aligned along the x, y, and z axis. 2 in each. Total of 6. D orbitals are 5 in number. 2 in each. Total of 10. Is it making sense? Did I answer your question? Alright. Guys, I'm going to skip bismuth. I'm going to go to zirconium. I'll come to bismuth in a minute. I just need you to follow along. How many of you are still confused with writing electron configurations? Alright. Joanna is going to help me. Joanna, zirconium has 40 electrons. Right? These 40 electrons start filling up the different orbitals. Where do you start? Always at the top. What is it? 1s, 2. What is after 1s? Run your finger as if you're reading sentences. 2s, 2. What is after 2s, 2? Joanna, after 2s, run your finger across. What is it? 2p. How many boxes? P is always 6. 2p 6. What do you hit after 2p? 3s. 3s what? 2. What is after 3s 2? 3p 6. What is after 3p 6? 4s 2. What comes after 4s 2? 3d. Where does zirconium stop? Oh wait, zirconium is in the next row. Alright, 3d what? Joanna, 10. After 3d 10, what is that? It's 4p6. What is after 4p6? 5s2. What is after 5s2? 4d2. Are we understanding it? Alright. Yes, please. Say that? Yes, we'll always start with 1 and 2. Okay, guys. I need you to stay with me as I do bismuth. Bismuth is going to be really, really long. Alright? If you can follow along, it's going to be awesome. Alright? Bismuth is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. I'm going to stop at 5p6. Are you with me, all of you? Alright? I need you to be paying careful attention. So I finished 5p6. Is that right? After 5p6, it is 6s2. You can write that also. Write 6s2. But here is the problem. 57 is here, 58 is here. 58 to 71 fills in. Rachel and Maddie, are you listening? Stay with me. So 58 to 71 fills in. And then what does it go back to? 72, and then it fills up to 80. Is that right? So the way I'm going to write the electron configuration is, after 5p6, it's 6s2. Are you with me? And then I go to 4f14. Count the boxes. They will be 14. Are you with me? After 4f14, I jump back up and I say it's 5d10. Are you with me? Yes. I come back to 5d10 and then it is 6p what? 6p3, and that is bismuth. Did we follow along? Yes. Are we understanding? All right. Yes. I can't hear you at all, Aru. Guys, can you be quiet? Can we hear what is her question?
That F was in the middle, like in
Yeah?
F was in the middle between D
Uh-huh.
and D.
Uh-huh.
Would you always put D before F when you're writing them?
In this case, the P was filled in, so I filled in the F, then I filled the D, then I filled the P. Is that correct? So let's make this cerium. Let's make this, well, this is abbreviated configuration. Let's just do cerium, all right? In the bottom of the page, let's just do cerium. Cerium has 58 electrons. Is that correct? So how will I write the electron configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. Are you with me? I completed all the way to 5p6. Now I am doing 55 and 56, which is 6s2. What is lanthanum? 57. Are you with me? So you will do 6s 5d1. Is lanthanum number 57? And there's only one. So it's 5d1. Jump down to cerium, it's 4f1. Does it make sense?
But if it wasn't Ethereum, then what have to do then?
Okay, so if you will continue to do the d1,
Then you go.
then you'll go into the f, yeah, 4f, and then you'll jump back to the d. Suppose you're writing, say I'm writing the electron configuration of tantalum. Are you with me? Are you with me? Tantalum is what number? 73. So, can I teach you what an abbreviated configuration is now? Everybody comfortable with writing electron configurations? Okay. You have to practice. Now, let me teach you tantalum. I need all eyes on the periodic table. Abbreviated means a shortened version. Is that right? Abbreviated means shortened. The abbreviated version also has the name that it's a noble gas configuration. What do they call it? Noble gas configuration. Now this is the noble gas column. Yes or no? So, tantalum is 73. Right? What is the noble gas before that? 54 is xenon. You know, instead of writing the electron configuration all the way from 1s1, 1s2, 2s2, and so on, in your abbreviated configuration, for 54 electrons, you will put xenon in square brackets. When I write xenon in square brackets, it means I have accounted for how many electrons? 54 of them, which is xenon. Is that right? After xenon, you will continue to write the electron configuration. So, it is 6s2 after that. Is that correct? Now, we are doing tantalum, mind you. Tantalum is 73. Lanthanum is 57. All of the F occupies and then it comes back to D. Yes or no? Yes or no? So the way I'm going to do this is I'm going to do 4F14. I don't write 5D1, 4F14 and then I come back. I do 6S2, 4F14 and where is tantalum? Tantalum is 5D1, 2, 3. I'll just write at the end that it's a 5D3. Let me do one more, Sam. Let's do one more electron configuration that's abbreviated. Alright? You're going to do iridium. Iridium is what number? 77. You're going to do the noble gas configuration. What is the noble gas you're going to choose again? Xenon. Who would like to help write the electron configuration after xenon for iridium? Who would like to try? Yes, Ryan.
Okay, on the board, or just like explain it?
You tell me and I'm going to write it.
Okay, so 6s2,
6s2,
then 4f14,
4f14,
and then let's see, 1, 2, 3, 4, 5, 6, 7. So 5d7.
5d7. Do we understand this? Alright? Let's do for chlorine. For chlorine, what is the noble gas you will choose? Neon. And then what is after neon? Who wants to help me? Who wants to help me? Yes, Sam.
3S2.
Huh? 3 what?
3s2.
3s2. And then what?
3p10.
3p.
10.
Count chlorine. Count the boxes.
Oh, geez, I can count.
Yes.
3p5.
5. 3p5. Are we good? Do we understand the entire configuration and the noble gas or the abbreviated configuration? Yes, Sam, what's your question?
2 questions now.
Yes.
Is there any way to show some like a noble gas is -1?
What?
Like you're 1 away from.
No, you can't do that. It's only further down the noble gas.
And then,
Okay? Yes.
You can skip the 57 and go from 56 to 58 by if it's half.
Which, give me an example.
Like the example you just did, where you went.
Yeah, that's just one there, right?
2 and then you went 4 at 14. And then
Yeah. And then I'll come back to 5D if I'm doing the D, which is after the F. Are you with me? Guys, understand this.
But then
If you are doing something in the F, are you with me? If you are doing something in the F, say you're asked to write an F configuration, you must remember to include the D1. You can't forget that. Alright? But if you are coming back to the D after the F has been filled in, then you can skip writing the D1 and instead do one single configuration for the D. Does it make sense? Are you understanding what I'm saying?
But then when you do the configuration, would you have to not include the 57? You have to start from the 72.
Which example, Sam, are you
So
doing
like it's the
constant?
W. So use the W, then it would
So it's the W, I'll do 56, I'll do the F, and then I'll come back and count 4 for tungsten in the D,
it would still be 4, not 3.
not 3.
Okay.
You don't write separate D1, separate D3. No. You write all the Ds together.
Okay.
Okay? Yes, Anissa.
Would you ever just write an abbreviated electron configuration for an element like hydrogen, like helium without the noble gas?
Helium they can ask. Honest to come on. Alright? For everything else they can ask.
Okay.
Peter, you have your hand up?
Yeah, what if it's in the one of the series at the bottom?
We said that include the D1. Don't forget that. Just follow the periodic table. Okay. Guys, let's move on. And I have a lot to teach actually. Alright. So they give you questions like this. Which element's electron configuration is this? Are these the number of electrons? Just add them up. Alright? Sometimes you will run into problems that are exceptions. We really haven't done the exceptions. So just don't look at the last electron configuration. Oh, it's 3s1 and it's sodium. Don't do that. Instead, count up the electrons. Alright? And if the number matches the number on the periodic table, you can figure out the element. Is it making sense? Alright? Count up the electrons and write that. So this is sodium. Okay? Now, let's move on. And what is wrong about these, we can do that later. So here are more practice problems on writing electron configurations, writing the noble gas configuration. Let's come to what an orbital diagram means. As it says, it's boxes and arrows. So somebody help me write the electron configuration of sodium. What is the electron configuration of sodium? 1s2, 2s2, 2p6, 3s1. Now, you have to know to draw boxes and arrows. Generally, for an S, how many boxes will you draw? Only one. There are 2 electrons inside the orbital, but how many boxes will you draw? 1. For P, how many boxes will you draw? 3. For D, how many will you draw? 5. And for F, 7.
Why do you draw half?
Because how many electrons can go into an orbital? 2. That's spin clockwise and counterclockwise. Okay? So So I'm going to draw the boxes and arrow diagram for this. This is my 1s, and I draw an up arrow and a down arrow. What does the up arrow mean? Clockwise spinning. What does the down arrow mean? The counterclockwise spinning. It's again the 2s. So again I draw how many boxes? Only one. And how many electrons are there? 2. And then how many boxes do I draw for 2p? 3. Now here is something my kids should know. When you fill in the boxes, it's completely full, it's okay. But sometimes it can be half filled. How do you fill? One in each box, and then you start doubling up. Okay? It is a rule that's known as Hund's rule. Alright? And then we'll come to 3s, which is 1. So let's do phosphorus. The electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Are you with me? So when we fill in these boxes, it's 1s2, it's 1 up and 1 down. 2s is 1 up and 1 down. 2p is 6, so I can probably put these arrows like that. It doesn't matter. 3s is just one box, 1 up and 1 down. Now it's the 3p. Is that right? So how do I draw my boxes and my arrows? How many boxes do I have? 3. And how will I draw my 3 arrows? 1 up in each. If I have a student drawing 3 boxes and showing me the electron configuration like this is wrong. Why is it wrong? What is the rule? Alright? So let's go to the next page and let's come down to the rules. There are 3 rules that we have to know. What is the first orbital we fill in? The 1s. Then what do we fill in? The 2s. Is that right? That's because they follow Aufbau's rule, which says lowest energy level first. Lower energy levels fill first before you start filling in the higher energy levels. Are you with me? So how many electrons do you put inside each box or each orbital? 2. Why can't you squeeze in the third? That's because of Pauli's exclusion principle. Remember, electrons hate each other. There is no space more than 2 in each. What does Pauli's exclusion principle state? We're going to write it in layman's language. No more than 2 electrons in each orbital. And how should the spins be? They should have opposite spins. They should have opposite spins. All right? So, what is Hund's rule? Hund's rule comes when you are trying to fill in the P, the D, and the F. Doesn't apply to S. All right? So when you have, say, 3 energy levels, how will you fill in the arrows or the electrons? 1 in each before you double up. Is that right? These are equal energy orbitals. What are they? They're equal in energy. All these 3 orbitals are equal in energy. It's like when you ride a bus. If there are vacant chairs, you want to go occupy the vacant chair. You don't want to sit next to a person. Electrons, by the way, hate each other. They repel each other, all right? So if there is an electron in this region of space, and there's one more electron coming in, it will go to another region of space. Does that make sense? The energy levels are equal. Hund's rule, 1 electron in each equal energy. Sometimes they write degenerate orbitals, equal energy. in each equal energy orbital before you pair up. There used to be a teacher who used to teach with me. She would say Hun starts with H, or it's the half-filled rule. Hun, half. That's the way you can remember. All right? Hun is the half. Aufbau, any kid who's taking German, Aufbau is a German word which means to fill up. All right? What does it mean? Yeah.
Wait, so someone's like name was literally what?
No, I don't think it's a name. It's a German word.
Oh, okay.
All right? Now, so that's how you will draw the orbital diagram if you're asked for an orbital diagram. Are we good with that? So, and this is, now let's look at the errors here. What is wrong when we write this electron configuration? What do you notice is wrong? 2 arrows up. What rule is being broken? Pauli's rule is being broken. What rule is being broken here?
What is that?
What is going on here? What is going on? Which rule is being broken here? Of course, the lower energy is not completely filled before you're going in. What rule is being broken here? Hans. Does it make sense? Yes.
But say in the C, because you have to draw 3 boxes, right?
Yeah. For the P it's 3, for the D it's 5.
But in 3 boxes, but then say it's part.
Okay?
That's only 2 arrows.
Yes. So how will you
So
put?
one
in each.
blank.
Yeah, one is blank.
Okay.
Exactly. There are only 2.
And then
I gave you a practice worksheet. You want to try those problems at home? Yeah.
would that same be for at the end of the second example be correct if it would say oxygen?
That is not oxygen. That's phosphorus. Right? 3p3 is phosphorus. Right?
Oh geez, like if it was, but if it was 3p3,
Then it's phosphorus.
but
It's 3p2, it's silicon.
why isn't that 3p4?
Because the arrow got put wrong. It's already violating a rule. It should have been there.
But if it was written like that,
It was written like that. That is going to be sulfur.
yeah, that would be cool.
That would be sulfur. You have to start pairing up when the place is not available. Yes, John?
On the one where you wrote all the boxes, please pull that one.
Okay. John, remember, all this is going to be not in the quiz. It's available for you as a video. Yes, it will be on the quiz. All right?
Will it just be the audio or boxes?
The video also, what I write on the board will also show up. Yes?
Those boxes mean the number of arrows you need.
The number of electrons.
Kind of like the 30.
Yeah.
And how come at 30?
Because that's the Hund's rule. The Hund's rule states if you have 3p boxes, you should fill 1 in each before you double up. Okay?
So you don't do down here?
Say if it's a P4, then how will you start doubling up? Say this isn't a P3, say it's a 3P4. Then you would do, that's the question Sam was asking. It's 1, 2, 3, and then now you start doubling up as a 4. Are we good? Okay, I am not yet done. All right? Did you guys get a sheet that said quantum numbers? We have 2 minutes left. Do you want to practice a little bit more? Is that what you want to do? Okay, maybe I'll not teach quantum numbers. Maybe you should practice. Do you have a practice sheet? Why don't you try practicing then? Go ahead, practice a little bit more. Nobilium. Anybody wants to do nobilium? 102. Not right again. Oh, that's cute. Should I stop my recording now then? I think I should. Yeah.